So I'm delighted that we're going to get an update on the climate science from the person who I regard as the world's leading climatologist, James Hansen, who for 32 years was NASA's lead climate scientist and head of the Goddard Institute of Space Studies. He was the climatologist who first told the U.S. Senate in June 1988 that we have human-induced global warming. I think you said you're 99% certain of that, and you were pilloried for it, but of course proven exactly on point as the years have gone on. Jim is a very difficult colleague because for 15 years, I think it's basically true that he always came up to me and said, Jeff, it's worse than we thought. And so I always a little bit shuddered to see him. He's one of the nicest people on the planet and also always with the most terrifying news. But we're very, very lucky that you're here, Jim, and we look forward to your presentation. Thanks.
Thank you. Can I have my first chart put up? Thank you. So thanks for inviting me, Jeff. Let's see, this way. Oh, there we go. So global temperature is the principal metric for climate change. When I wrote my first major paper in 1980, global warming was 0.4 of a degree. When I testified a decade later, it was 0.6 of a degree. And in 1998, we had this El Nino of the century, which raised the global warming to 0.9 of a degree Celsius relative to pre-industrial. And that was such a strong El Nino that it allowed the contrarians for 15 years to say, look, there's no more global warming. It's not any warmer than it was in 1998. But then the last several years, the temperature has risen far above, even above 1 degree Celsius with the most recent strong El Nino. Now, there's no reason. So the warming has been essentially linear for the last half century. There's no reason that it should be linear. And in fact, I will argue that we're now getting off of this linear track. Global warming is actually accelerating. While we had agreed in the Framework Convention that we would get it to decelerate and put a limit of 2 degrees or even 1.5 degrees on global warming. But if you compare the peaks, the last 2 El Ninos, and this recent one was not really as strong as the one in 1998, and yet the warming between those peaks is 0.21 degrees Celsius. And if we compare the temperature at the depths of the La Niñas, the cold phase, the warming rate is even larger in the last decade. I think the underlying rate is in between those 2 numbers, but it's larger than the 0.17 degrees per decade. And there's a reason for that. We should look at what's forcing this global warming. Well, the carbon dioxide increase had been, for the last couple of decades, about 2 parts per million per year. The last 5 years, it's been about 2.5 parts per million per year. And in the methane, which had stabilized in amount for about a decade, is now increasing again rapidly. And that may be partly because of fracking, the leakage of methane that occurs in fracking, but also seems to be due to wetlands, increasing emission from wetlands. And that's a climate feedback. It's one of the reasons that we have to get the forcing under control, because we're driving feedbacks that amplify the response. Well, we can look at the net effect of all the greenhouse gases very precisely now because we're measuring these gases. And for a decade or two, it had been increasing. This is a measure of the added forcing in watts per meter squared per year, which was about 4/100ths of a watt for several years, but now the last 5 years or so is increasing even faster because of both CO2 and methane increasing more rapidly. And that's why the global warming rate is accelerating. And you can see how far we are off of the pathway that was defined to get us to 1.5 degrees Celsius. Just in 1 year, the gap, 0.016 watts per meter squared. Well, you can say, oh, well, there's a small gap there. Let's close that gap by sucking some CO2 out of the atmosphere. Well, we can do that. We now know how to do that. And you look at the cost of that, we would have to take out, in order to close the gap of just 1 year, we have to suck 2 ppm of CO2 out of the air. That is a cost, using the cost that David Keith, with his carbon capture that they've developed and shown that it can work, gives us a cost estimate. And so the single year cost estimate is between $2 and $4 trillion per year to close that gap. And you have to do that each year. And the gap is increasing each year. So I would argue that that's not possible. You can't, the governments are not going to provide that $2 to $4 trillion. We can't even get $100 billion for climate purposes. So how are we going to get, so we have to reduce, and of course the reason that that gap is growing is because the energy use continues to be primarily fossil fuels, and it continues to grow. And so the gap is growing. And the temperature is now well outside the range that has existed during the Holocene, the last 10,000 years during which civilization developed. And it's now going into the level of temperatures of the Eemian, 120,000 years ago, when sea level was 6 to 9 meters higher. We know that if we stay at 1.5, 2 degrees global warming indefinitely, that sea level will go up and we will lose all coastal cities. So it's a question of how fast. So we have to get on a path that, because more than half of the large global cities are on coastlines. So we can't go down that path. Or it's just an unacceptable outcome. That's the one of the irreversible effects of allowing continued high fossil fuel emissions. The other one is extermination of species. We're putting stresses on species in many different ways, but when that's combined with rapidly shifting climate zones, it threatens extermination of a significant fraction of the species. There was just a report a week or two ago from the United Nations on biodiversity, which didn't get as much publicity as it deserved. But it's not just a theory. You know, we see this happening already with the coral reefs, which are the harbor for 1 million species. Because of ocean acidification, warming of the ocean, and the other stresses, we're losing 1 to 2% of them per year. It's an urgent issue. Besides these irreversible effects, the regional climate effects are becoming apparent, especially the summer in subtropics, like the Southwest United States and Mediterranean region and the Middle East. Every summer is now warmer than it was last century. And the tropics in areas such as Southeast Asia are also becoming warmer, significantly warmer. So it's becoming uncomfortably hot in these seasons and places, so that it's not possible to work outdoors. If this continues, if we stay on this business as usual path, it's not going to be possible to work outdoors in agricultural and labor and construction. So that will increase the migration pressure because those regions are becoming unlivable. So this, the regional impact of this shifting bell curves is that the dry regions become hotter and drier, and wet regions become greater floods and storms, and that is becoming noticeable. Let's see, there we go. But, you know, I remind you, we do still have a great planet that is worth preserving. So I don't want to just show you the bad things. It's worth taking the actions that are needed, because the potential injustices are, especially today's adults to young people, but the industrial north to the low latitudes, and of course the humans to all other species. And we can see these things happening. The fires are becoming more extreme. I could show many, Australia recently and California in the United States. The effects are becoming noticeable to people. And you can look at the statistics and you see that it's really happening. The floods, the 100-year flood is now occurring more than once a century. It's one of the things that we predicted, and it is happening. This was in Japan a year ago, where record floods. And the storms that are driven by latent heat and ocean surface temperature are becoming stronger. Kerry Emanuel showed from our climate model that if doubled CO2 would cause the minimum pressure in tropical storms to decrease from 880 millibars to 800 millibars and increase the maximum wind speed by 50 miles an hour. Well, we're beginning to see that. It doesn't mean that every storm is going to have maximum wind strength, but the most extreme ones are going to be more extreme. And it's those small number of very extreme storms that cause the most damage. So the bottom line is, you know, we have a crisis, and it's not very well recognized by the public. Because it's a crisis caused by the delayed response of the system and the amplifying feedbacks, which mean that we're in danger of handing young people a climate system that's out of their control. And now I'm getting to the economics part. That's for the other speakers, but thanks very much.
Like I told you, always extraordinarily sobering. Just to underscore the point, and if you haven't heard it clearly, we're outside of the range of the entire civilization history already. We're warmer than the last 10,000 years and accelerating warming, and with several absolutely catastrophic prospects, and we haven't succeeded in even changing the sign on the emissions yet, which are continuing to rise.